This is an example from our homework section. A bank administrator wants to analyze age and savings account for 8 of their customers. The data below gives the age in years that they are and the amount of savings rounded to their nearest whole dollar amount. Can you predict the savings a person has by the age they are? So basically, I always open a blank that says blank depends on blank. And in this case, it says, can you predict the savings by their age? So their savings depends on how old they are. Savings depends on age. So I always do that. I try to make common sense out of what the question is asking. So make sure you pay attention to the question of the problem. Then what I do is using this chart below, it makes savings depends on age. So savings is the dependent variable, which we also call our Y variable, which in Minis tab we have to use response variable. Those are all the same thing. And I know that's confusing to some students, so I hope that helps. And then if savings is the dependent variable, the other variable, which is age, would be your independent variable. So age is independent variable, which is also your X variable, which is called your predictor variable in Minitab. Not only do I do that, but when I put them into Minitab, if you'll look over here, when I put them into Minitab, I put them in that same way because that will help me later on when I'm trying to put my variables in because I get my variables confused. So I wanted to make sure that you're able to do that. The first two questions typically are what is your independent variable and what is your dependent variable? So again, our independent variable is age, our dependent variable is savings. Okay, so we'll continue on with that. Let's go over and use Minitab to perform the linear regression model. So we do stat, regression, regression, fit regression model. Now, our response variable, now that I've listed them this way, I just have to come over and pick the one that says response. And for our predictor variable, I choose the one that says predictor. Or you can always remember that your response variable goes first, which is your Y and your X. However you want, and I think this chart helps people as well, how you wish to remember those. I know it's a little confusing that they use different terms in Minitab as we use with our X and Y variables and with dependent and independent variables. So click OK, and it gives us all this information here. The first thing we're going to do is look at the regression equation. Here it is. That is the line of best fit, or the line that fits all these points on a scatter plot. So it's the line that kind of fits in between all these. Now the questions you'll be asked on that is what is your y-intercept and what is the slope? So what I want to remind you of is, like in algebra, you learn that your regular equation is y equals mx plus b, that was the equation of a line. Okay, notice that b in algebra was our y-intercept, and that's the number that's out there by itself, not attached or multiplied by the variable x. So that's your y-intercept. So our y-intercept is negative 15816 because it's the number over here that's not multiplied against the variable. And then the slope is your m, which is the number up against the variable x. So our slope is 683. So I hope that helps you distinguish that. The next thing we're asked is what is our R variable? So I'm going to pull this down. All you have to do is kind of grab it, pull it down. And we don't know, our model summary gives us R squared, but it doesn't give us R. So what you have to do is you take R squared. It's given in a percentage because we're going to use it as a percent later on. And you have to change it to a decimal. So you move the decimal 2 places to the left to change from a percent to a decimal. That's 0.1708. And then since that's R squared, the way that you undo R squared is to take the square root of it. So to find out what R is when you have R squared is you take the square root of the number. So we're going to take the square root of 0.1708, and you should get 413 thousandths, or 0.413. What does that value indicate? Okay, so we'll just say it's about 0.4. Okay, so let's talk about that for just a minute. R is always going to be a number, which is 1, -1, and all the decimals in between there. Okay, 0 means that you have no correlation at all. So if R is equal to 0, that means that your age and savings have nothing to do with one another. There's no correlation between the two. As we get closer to 1, then it becomes weak, moderate, and strong correlations. Okay. And again, going to +1, or you can have a negative correlation. Also, it just depends on, um, actually, that is dependent on the sign of your slope. If your slope is negative, it's a negative correlation. If the slope is positive, it's a positive correlation. Again, we got 0.4, which wouldn't really be weak. It's probably more of moderate. It's a weak to moderate. But our problem gives us 3 choices: moderate positive, weak positive, or strong positive. Well, it's not strong. 0.4 is not near 1, and it's not weak, because 0.3 and below pretty much would be weak. So it's a little over 0.4, and that's considered a moderate, and it was a positive number, positive relationship. Okay. Okay, then the next question is, what is your R squared value, and round it to 4 decimal places. Again, we get that from our chart. 17.08% is our R squared value. As a decimal, that's 0.1708. The next question says, what does that value indicate about the relationship? And what that percentage indicates is that the dependent variable, only that percent of the variation in the dependent variable can be determined by the variation of the independent variable. That means a very low percentage of the variation in your savings amount can actually be determined by your age. So that is the importance of the R squared. The next question, which is the biggie, is the 0.05 level of significance. We have to find out if there's a correlation between the two variables or not. And this can take a minute. So let me explain that for a minute to actually be a very simple answer of yes or no. But so rho, which is kind of an italics P, which is the Greek symbol for the population correlation. So all this time we've been talking about R. R is the correlation of this specific sample. So now when you go to hypothesize, you always use the population like we've done this whole second half of the course. So if rho equals 0, so if, remember, your null hypothesis is always the equal part. Your alternate hypothesis is the not equal part. So the equal part is if rho is 0 and HA, which is the opposite, is rho does not equal 0. So either rho equals 0 or rho does not equal 0. If rho ends up equaling 0, remember the picture up here? There's no correlation. So if rho is 0, there'd be no correlation, and you cannot use the regression equation. If rho doesn't equal 0, the correlation is not 0, then we would determine that there's a relationship between the two variables, and you can use the regression equation to make predictions. So let's do what we usually do with our HO and our HA. If P is less than 0.5, then reject the null hypothesis. That's what you always do. P in this problem is you come over here and you get the regression p-value. This would be the regression test value, but this is the regression p-value, which is 0.309. So if p is less than 0.050, then reject HO. I got 0.05 from our original problem because it told us, or if it doesn't tell us, oh, I think it asked us in the question, yeah, at the 0.05 level of significance. So if P is less than our level of significance, then we're going to reject the HO. We're going to reject our null hypothesis. It is not less than, so we're not rejecting our null. That means our answer comes from the null in purple up here, which purple says there is no correlation and we cannot predict with the regression equation. This little box I've made up helps you with that as well. So we don't reject HO, we answer with our HO, and there's no correlation. We cannot predict our regression equation, which is kind of this little box here should help you with the null hypothesis and alternate hypothesis for these problems. So the last questions are, can you make, oh, well, did we answer this? No, there's not a correlation. The next question is, can you make predictions? No, I can't make predictions. If you can make predictions when the age is 30, what's the savings amount? If you can't make predictions, put the word none in the blank. So your answer here is in purple is none. But if you could, then let me just show you very quickly what you would do. You just plug in age equals 30 in your regression equation right here. The regression equation was savings equals 0.15816 plus 683, and you would plug in the age there of 30 and calculate that to see what the savings would be if a person was 30 years of age. So I hope that helps you walk through an entire regression problem. I do want to look at one more, just real quickly. Let's look at one more so we can make sure you're getting your dependent and independent variables correct. Because like I said, if you can't get those, then you're having a hard time with anything else. Okay, so let's take a look at this. Again, I'm going to open up blank depends on blank, and I'm going to read the problem. A credit card company wants to know if there's a correlation between the number of credit cards a person has and their amount of debt. The number of credit cards and the amount of debts are reported as a whole number, so both of them are whole numbers is all that's saying. Can you predict your amount of debt by the number of credit cards you have? So that is, does your debt depend on credit cards? So debt depends on credit cards. Debt becomes your dependent variable, response and Y variable. And the other one is your independent variable. So number of credit cards is your independent variable, your predictive variable, your X variable. So I have those listed here. And again, I always do this just to keep myself straight. So I hope that helps you also keep yourself straight with the types of variables that you have, which one's dependent and which one's independent. Just let me know if you have further questions.